Imagine walking up to a fast food drive-through speaker, asking for a burger, and realizing the microphone isn't just passively recording your order.
Right.
It's actively pinging the global supply chain. It's firing up the kitchen's fryers, auditing your loyalty points, and checking the weather to see if you might, want a hot coffee instead.
All at the exact same time.
Exactly. And it's doing all of this while holding a completely natural conversation with you. It's talking while its digital hands are simultaneously doing 10 different things in the background.
Which is pretty incredible.
Up until very recently, that was basically science fiction. But looking at the data we have from April 19th to April 25th, 2026, Amazon Bedrock just made that the new baseline for enterprise computing.
That is exactly the scale of the transition we're observing right now.
Mm-hmm.
We are moving well past the era where generative AI was essentially a parlor trick.
Yeah.
A standalone application where you send a text prompt and then you just patiently wait for a text response.
Right, the chatbot phase.
It's exactly. The developments over this specific 7-day window demonstrate that Bedrock has officially evolved into a fully integrated, silicon-anchored, agentic operating system.
Wow.
We are looking at the foundational infrastructure for an autonomous digital workforce.
Okay, let's unpack this, starting with how we actually design and architect these next-generation agents. Think of us as your expert guides to this week's AI ecosystem, because our mission today is to distill a huge stack of highly technical sources.
And there are a lot of them.
Oh, yeah. We've got the AWS News blog, the AWS Machine Learning blog, AWS Security Bulletins, corporate press releases, and we're boiling it all down to the essential Bedrock AI updates published exclusively within this past week.
Right.
Because, you can't just slap a voice model onto a database and hope for the best. I was reading through the AWS Machine Learning blog published globally on April 20th, and they released this fascinating reference architecture for what they call omni-channel ordering.
Yes, that was a major release.
And it combines Bedrock Agent Core with their new Amazon Nova 2 Sonic speech-to-speech foundation model. And, the technical specifics of how they pull this off are just wild.
The underlying mechanics are really the story here. They're utilizing the Agent Core runtime to host these agents inside isolated micro-VMs.
Micro-VMs. Okay, let's pause there.
Sure. To visualize that, a micro-VM is essentially a tiny, highly secure individual virtual computer, and it gets spun up in milliseconds for every single customer interaction.
Okay, so it's not a shared space.
Not at all. It is completely firewalled off from everything else.
Right, so if I'm the customer talking to the agent, my session is trapped in this little sandbox.
Precisely. And within that sandbox, they are executing WebSockets, streaming with SIGV4 signed connections, streaming audio bidirectionally at 16 kilohertz PCM.
Okay, let's break that down for a second, because that is a very dense stack of technology.
It is, yeah.
Streaming 16 kilohertz PCM means they are pushing raw, uncompressed audio back and forth instantly.
Yes.
But doing that securely is usually a total nightmare.
It's a massive engineering bottleneck. And that is where the SIGV4, or Signature Version 4, comes in. It is AWS's cryptographic protocol.
Yeah, okay.
Every single packet of that uncompressed audio stream is mathematically signed using identity and access management credentials.
So it's locked down tight.
Think of it as the data flowing through a mathematically sealed vault door in real time. The system knows, with absolute cryptographic certainty, that the agent is only communicating with authorized endpoints.
And while it's talking to you through this sealed vault door, it's also executing parallel asynchronous tool calls, which brings us back to the drive-through speaker analogy I mentioned earlier.
Right.
Previously, an AI had to listen, stop, think, query a database, wait for the database, and then talk.
It was strictly sequential.
Exactly. It was so clunky. Now, because of these asynchronous tool calls, the agent's brain and hands operate completely independently. It can listen to you change your mind about, wanting fries instead of onion rings, while its hands are simultaneously processing your credit card and updating the kitchen inventory.
Which fundamentally establishes the canonical pattern for moving voice agent prototypes into real-world production.
Yeah.
It proves that you can run highly complex, multi-step agentic workflows without experiencing the latency that completely ruins the illusion of a natural conversation.
But building that perfect mathematically sealed micro VM is just step one, right?
Right.
It's great if you're deploying one agent for a local prototype, but if you are a massive global enterprise, you need to deploy tens of thousands of these digital workers.
And you need a way to manage them without causing a massive data leak.
Exactly. Which leads us directly into the product and platform updates released this week. There was a massive global announcement on April 21st, also on the AWS machine learning blog regarding Claude Cowork.
Yes, the Anthropic partnership.
Right. So Anthropic's Claude Cowork desktop app introduced a new deployment mode specifically for enterprise IT.
And this is huge for data governance. It allows administrators to route all of the model's inference strictly through Amazon Bedrock using AWS IAM or Bedrock API keys.
So the data isn't going out to the public Anthropic servers anymore.
Exactly.
It's staying entirely within the company's existing AWS perimeter.
Yes. In fact, to enforce that strict data residency, Anthropic-hosted features like the chat tab and their computer use functionality are completely disabled in this mode.
Wow.
It effectively turns Amazon Bedrock into the enterprise control plane for Claude desktop agents.
That feels like a massive shift in how these tools are licensed and adopted.
It really is.
Because if I'm an IT director at, say, a heavily regulated bank or a healthcare provider, I've been terrified of my employees putting patient data into a public chatbot.
Rightfully so.
But with this, I can adopt team-based AI workflows, maintain my strict AWS security boundaries, and I don't have to pay massive per-seat licensing fees to a third party.
Exactly.
I'm just paying for the Bedrock inference consumption on my existing cloud bill.
It completely removes the friction of enterprise adoption. And AWS followed that up immediately. The very next day, April 22nd, they launched a preview in 4 regions, US West, US East, EU Central, and AP Southeast, for Amazon Bedrock Agent Core.
Oh, right, the managed harness.
Yes, they introduced what they are calling a managed agent harness.
I spent a lot of time looking at this managed harness, and honestly, it feels like a cheat code for developers.
It really does.
Normally, to build an agent, you have to write a massive amount of orchestration boilerplate. You have to build the cognitive loop, the code that tells the AI, okay, read the prompt, search your memory, decide if you need a tool, format the JSON to use the tool, wait for the response, and then finally formulate your answer.
It is incredibly tedious, complex code.
Yeah. And the managed harness just completely removes that.
It handles the entire cognitive loop for you. You just specify the model, define the system prompt, hand it a list of tools, and the harness takes over.
Just like that.
Just like that. It manages the reasoning and the action execution. And just like the omnichannel ordering example, it instantly places each of these sessions into its own secure micro VM with file system and shell access.
They also rolled out the Agent Core CLI, the command line interface, globally across 14 regions for AWS CDK deployments.
Right.
You can now build declarative agents in just 3 API calls. You can even dynamically switch models mid-session without rewriting your code.
That's a huge feature.
It is. So if you start a task with a smaller, cheaper model and it suddenly gets confused by a complex reasoning request, the harness can hot swap to Claude 3.5 Sonnet on the fly to solve it and then swap back.
What's fascinating here is the sheer velocity this enables. You go from a local prototype to a highly scalable, dynamically routed agent in minutes rather than months.
But I have to push back a little on this, though.
Oh.
Yeah, if AWS is abstracting away all of the orchestration code, if they are the ones managing the cognitive loop and the memory state, doesn't that risk severe developer lock-in?
I see what you mean.
It feels like we are all being handed the keys to a sports car with an automatic transmission. It's incredibly fast and easy to drive, but if you want to tweak how the gears shift, or if you need to build a custom transmission for a very specific enterprise use case, you can't. You don't have access to the underlying mechanics.
That is the classic trade-off between managed services and open source. However, AWS anticipated that exact concern. The Agent Core harness actually includes an export function that generates open-source strands-based code.
Okay, for anyone not deep in the weeds, what exactly is Strands?
Strands is a popular open-source framework used to build agentic workflows. It structures the agent's thought process as a declarative graph, basically a highly detailed flowchart of nodes and edges.
Got it.
So if you're using the AWS managed harness and your enterprise agent suddenly grows so complex that you need full manual control over the orchestration logic, you are trapped.
You just hit export.
Exactly. AWS gives you the raw strands graph, you have your manual transmission, you can rewrite the nodes and customize the memory architecture completely on your own. It acts as an accelerator, but it provides a critical escape hatch.
Okay, that is a very smart safety valve. And speaking of removing friction, we also saw SageMaker AI launch a generative AI inference recommendation engine globally on April 22nd.
Yes.
Because once you build these agents, figuring out the physical servers to run them on is a nightmare.
It is incredibly difficult to estimate. Previously, determining the right infrastructure required weeks of manual benchmarking. Engineers were running simulated workloads, guessing at instance types, and adjusting parallelism strategies through trial and error.
And if they guessed wrong, they either crashed the app or over-provisioned the hardware and wasted thousands of dollars.
Which happens a lot.
Right. But this new SageMaker feature automatically profiles your customized Bedrock model and spits out the exact deployment configuration you need. It drops the deployment cycle from weeks to hours.
Which directly impacts the return on investment. You're paying for exactly the compute required to meet your latency goals, and not $1 more.
But here's the catch.
Okay.
You can build the perfect micro VM, write the ultimate strands graph, and optimize your deployment perfectly. But then you try to scale this up. You try to deploy 10 million of these autonomous agents across a global workforce.
Right.
And the sheer computational weight of running that many micro VMs just crushes your standard infrastructure. To make this actually work, you need entirely different physical hardware.
The physical layer dictates what is actually possible in software. And on April 24th, we saw a staggering validation of that reality.
The meta news.
Exactly. Meta signed an agreement with AWS to deploy tens of millions of AWS Graviton processor cores, specifically to power their next-generation agentic AI workloads.
Tens of millions of cores. I mean, that scale is almost impossible to visualize.
It is massive.
And what stood out to me from the About Amazon post is that they aren't using these chips to train models. They're using them for real-time reasoning, code generation, and multi-step task orchestration.
Which proves a fundamental shift in AI architecture. Massive-scale agent deployments require highly efficient CPU compute. Specifically, they are using Graviton 5, which features 192 cores per chip.
Here's where it gets really interesting, because for the last 3 years, the entire tech industry has been obsessing over GPUs.
Graphics processing units, yes.
Right. But if we think about the architecture, it makes perfect sense why Meta is pivoting to CPUs for agents. A GPU is basically a massive array of simple calculators. It is designed to do millions of matrix math operations simultaneously.
Correct.
If we use an analogy, traditional GPUs are like the highly creative, eccentric artists locked in a studio. They're doing the incredibly dense, heavy lifting of painting the masterpiece, which is training the neural network's weights.
But an autonomous agent operating in the real world isn't doing matrix math. When an agent is waiting for an API response from a flight booking system, or deciding whether to query a database or send an email, it is executing branching logic. It is evaluating if this, then that.
And CPUs are designed specifically for complex branching operations and maintaining state across isolated tasks. So if the GPUs are the artists creating the model, the Graviton CPUs are the rigorous gallery managers.
I like that analogy.
Right. They are out on the floor, coordinating the logistics, talking to the clients, managing the schedules, and actually running the business. You need the artist to create the AI, but you absolutely need the gallery manager to deploy it.
And at Meta's scale, doing that orchestration on standard off-the-shelf CPUs would be economically devastating.
Power consumption alone.
Yeah. The power consumption would be unsustainable. By utilizing Graviton 5 with its 192 cores, you can pack hundreds of these isolated micro VM agents onto a single piece of silicon. It dramatically lowers the total cost of ownership, allowing you to actually deploy millions of agents without bankrupting the enterprise.
But, scaling hardware and deploying millions of autonomous agents with digital hands introduces a pretty terrifying reality.
It does.
When an agent can act on its own, your attack surface multiplies exponentially. The security of the infrastructure must be flawless. Which brings us to the less glamorous, but arguably the most critical data point we analyzed this week.
Yes. On April 20th, AWS published a Global Security Bulletin, CVE 2026-4269.
Right.
It detailed a missing S3 ownership verification vulnerability in the Bedrock Agent Core Starter Toolkit. This specifically impacted versions prior to its 0.1.13 that were created after September 24th, 2025.
Now, missing S3 ownership verification sounds like a minor administrative error, like someone just forgot to check a box.
It sounds benign.
Yeah, but the bulletin explicitly states this flaw could allow remote code execution, or RCE, directly inside the Agent Core runtime service.
This raises an important question, specifically regarding the balance of development speed versus infrastructure security in an agentic world.
Because RCE is as bad as it gets.
It is. Let's walk through exactly how this exploit functions. When you use the Agent Core Starter Toolkit, It automatically provisions the backend infrastructure for your new agent.
Okay.
Part of that process involves creating an S3 storage bucket to hold the agent's initial system prompts and instructions.
Right, the file that tells the agent you are a helpful customer service bot.
Precisely. Because the toolkit was failing to cryptographically verify who actually owned that S3 bucket during the setup phase, a sophisticated attacker could potentially monitor the network, register the expected bucket name first, or spoof the routing.
Wait, so the attacker sneaks in and owns the bucket that your agent is going to read from?
Yes. So when your brand new micro VM boots up and says, "What is my job?" it reaches out to that compromised bucket.
Oh, wow.
But instead of reading a text file that says you are a helpful bot, it reads a malicious shell script uploaded by the hacker.
And because, as we discussed earlier, these agent core micro VMs are designed to have file system and shell access so they can use tools, the micro VM just blindly executes the hacker's script.
It executes it with all the permissions granted to that agent.
That's terrifying.
It could immediately begin exfiltrating your customer databases, sending malicious emails internally, or pivoting to attack other nodes in your network.
That is a chilling scenario. A remote code execution flaw in an autonomous agent isn't just a traditional data leak. It is literally a hostile takeover of a digital employee. The bad actor now controls the hands you built.
Which is why this represents a critical supply chain risk for Bedrock developers. It emphasizes the absolute necessity of immediately upgrading to version 0.1.13 to prevent malicious code injection.
Right.
But zooming out, it is a stark reminder that as our infrastructure becomes more autonomous, traditional cybersecurity hygiene doesn't become obsolete. It becomes the only thing preventing systemic compromise.
Yeah, you are no longer just securing static data in a database. You are attempting to secure active reasoning participants in your network. Securing an active participant. That completely changes the threat model. But while these vulnerabilities remind us of the incredibly high stakes involved in giving AI autonomy, the sheer volume of capital moving through this space proves that the major players believe the rewards exponentially outweigh those risks.
They absolutely do.
They are placing historic bets, and they are placing them squarely on AWS custom silicon. Let's look at the financials from this week, because this is wild.
The capstone event occurred on April 20th. Anthropic and Amazon announced an expansion of their collaboration that fundamentally alters the landscape of frontier models.
Right, from the Anthropic news and AWS press releases.
Amazon invested an initial $5 billion into Anthropic, with a framework that allows for up to $25 billion in total investment.
But you know, Amazon giving Anthropic money isn't really the real story here.
No, it's not.
The truly significant part of this global announcement is what Anthropic committed to in return. They committed over $100 billion over the next 10 years to AWS technologies.
And they secured up to 5 gigawatts of compute capacity across Amazon's custom AI training chips, Trainium 2, Trainium 3, and future Trainium 4 architectures.
I really want to look at the numbers here because there is a detail in the financial reporting that is absolutely fascinating.
The valuation.
Yes, that $5 billion fresh investment round was priced at a $350 billion valuation for Anthropic. Now, if you follow the secondary markets, that is a steep discount.
Very steep.
Anthropic's equity is incredibly highly sought after. Why would they take a discount? Does this mean Amazon is basically using its Trainium compute capacity as capital? Like, are they literally trading server racks and electricity for equity?
If we connect this to the bigger picture, the answer is a resounding yes. In the modern AI arms race, liquid cash is becoming a secondary currency.
Wow.
What actually matters are the physical constraints of reality, guaranteed power and dedicated silicon.
And 5 gigawatts is an astronomical amount of power.
It is hard to even fathom.
That is roughly the equivalent output of 5 full-scale nuclear reactors dedicated solely to running these models.
Exactly. Amazon leveraged their massive physical infrastructure, the utility power agreements, and their million-plus operational Trainium 2 chips to secure a favorable valuation.
Makes total sense.
But more importantly, they secured a decade-long lock-in. This historic vertical integration anchors Claude Inference exclusively to Amazon Bedrock and AWS hardware for the next 10 years.
It really redefines what it means to be a cloud provider. They aren't just renting out empty server space anymore.
Not at all.
They have maneuvered themselves into being the sole source of the basic raw materials required for artificial intelligence to exist. They control the power grid, they design the silicon, they build the micro VMs, and now they own a massive stake in the actual reasoning engine itself.
And by locking Anthropic's ecosystem into Trainium, AWS ensures that the unit economics of running Claude on Bedrock will remain highly competitive. They control the entire stack, from the physical silicon substrate all the way up to the Agent Core API-managed harness we discussed earlier.
So, what does this all mean for you? Whether you are an enterprise architect trying to map out your company's IT strategy for the next 5 years, or you're a curious developer hacking on weekend projects, the takeaway from this week's data is undeniable.
It is a clear paradigm shift.
Building an AI agent is no longer about wrangling a dozen disparate, flaky APIs from different vendors and trying to duct tape them together.
Right.
It is about leveraging a unified, highly secure operating system Bedrock that is heavily subsidized and optimized by custom silicon like Graviton and Trainium. The drive-through speaker we started this conversation with, it has a brain, it has hands, it operates inside its own cryptographically sealed workspace, and it has the entire AWS global infrastructure powering its logic.
It really forces a shift in how we perceive corporate infrastructure.
Hmm.
If an enterprise is building OS-level agents with Bedrock, integrating them deeply into corporate workflows with tools like Claude Cowork, and running them on Anthropic models that are strictly locked to AWS hardware for the next decade.
Yeah.
At what point does the cloud provider cease to be just a software host and instead become a digital staffing agency leasing out an autonomous workforce?
Wow. Now that is the thought that is going to keep me up tonight, a digital staffing agency.
It changes everything.
You aren't renting compute instances anymore, you are leasing employees by the millisecond. We're going to leave you with that to chew on. Keep questioning the assumptions of what cloud computing actually is, because as the period between April 19th and April 25th proved, the definition is changing faster than ever. Stay curious.